Okay, so this is Year 12's Chapter 2, Constant Acceleration exam question. I'm going through question 2 on this assessment paper. So, as we know, so a ball is being projected vertically upwards with a speed 14.7 from a point which is 49 meters above the horizontal ground. So, 49 meters above the horizontal ground is being projected upwards with initial velocity 14.7. So we would like to work out the greatest height above the ground. So the ball is going to be projected upwards, it's going to reach, it's going to stop here, final velocity is going to be equal to 0. And what we would like to first of all to work out is this distance. So if I'm going to use the Suvat equation, it's going to be v squared is u squared plus 2as. So therefore the final velocity as it's going to reach the greatest height is 0. Initial velocity is 14.7 squared plus 2 times acceleration is moving against gravity is minus 9.8 multiplied by the distance. So the distance, it must be 11.025 meters. But the question itself, they asking you to find the greatest height above the ground. So therefore the greatest height is going to be the total distance traveled must be 11.025 at 49, which is 60 meters. It's moving 60 meters above the horizontal ground. For question B, we would like to find the speed with which the ball is going to strike the ground. So strike the ground in this point just before here, we would like to work out the velocity. So for part B, I'm going to use the Suvat equation again. So I'm using v squared is u squared plus 2as. So I would like to work out velocity as it's going to strike the ground. It's 14.7 squared plus 2 times minus 9.8. I'm going to consider this as positive direction. It's moving again against gravity, multiplied by, and it's being projected below the ground from a point below the ground, 49 meters below the ground. So I'm going to work out the velocity. It's going to be 34.3 meters seconds minus 1. So for part C, we would like to work out the total time from when the ball is projected to when it first is going to strike the ground. So for part C, again, we are going to use the Suvat equation. We want to work out the time. So I'm going to have S is ut plus a half at squared. So I'm going to consider the distance is going to be minus 49. It's been projected from a point below the ground, from a point above the ground. So below the point of projection, so if I'm using 14.7 t plus this is my positive direction, so it's going to be a half times minus 9.8 t squared. I have a quadratic, so I'm going to start to rearrange and simplify. So it's 14.7 t minus 4.9 t squared. If I do start to rearrange, I have 4.9 t squared minus 14.7 t minus 49, make this equal to 0. I would like to divide everything by 4.9. I get t squared minus 3t and minus 10, make this equal to 0, which now I can factorize. I have t minus 5 and t plus 2, so the time must be positive, the time must be then 5 seconds. Thank you.